we will study about the atomicity. The number of atoms present in one molecule of an element or compound is called it atomicity. Number of atoms present in one molecule of an element or compound is called its atomicity. For example, here we can write a table, we can draw a table, element or compound, and here we can write atomicity. First one is chlorine. As we know, the molecular formula of chlorine is Cl2. It means 2 atoms of chlorine present in one molecule of chlorine. So we can write the atomicity of chlorine is 2. Then for hydrogen, the molecular formula is S2. It means 2 atoms of hydrogen present in one molecule of hydrogen. It means the atomicity of hydrogen is 2. Then we can write nitrogen. As we know, the molecular formula of nitrogen is N2. It means 2 atoms of nitrogen present in one molecule of nitrogen. So we can write the atomicity of nitrogen is 2. Now ozone, the molecular formula of ozone is O3. Then we can write the atomicity of ozone is 3 because 3 oxygen atoms present in one molecule of ozone. But for oxygen, the molecular formula is O2, and we write atomicity 2 because 2 atoms of oxygen present in one molecule of oxygen. Now for sulfur, molecular formula is acid. It means 8 molecules present in 8 atoms present in one molecule of sulfur. So we can write the atomicity of sulfur is 8. Now for phosphorus, molecular formula is P4. So we can say that 4 atoms of phosphorus present in one molecule of phosphorus. So we can write the atomicity of phosphorus 4. Now for hydrogen chloride, molecular formula is HCl. As we know, 1 atom of hydrogen and 1 atom of chlorine present in one molecule of hydrogen chloride. So we can say that 2 atoms present in one molecule, then we can write the atomicity of HCl 2. Now for sulfuric acid, molecular formula is H2SO4. So we can say that 2 atoms of hydrogen and 1 atom of sulfur and 4 atoms of oxygen present in one molecule of sulfuric acid, and the total is 7. So we can write the atomicity of sulfuric acid 7. And for carbon dioxide, the molecular formula is CO2. As we see, 1 atom of carbon and 2 atom of oxygen present in one molecule of carbon dioxide. The total is 3. So the atomicity of carbon dioxide is 3. Note, as we know, inert gases exist in monoatomic form. Inert gases exist in monoatomic form. So we can say that the atomicity of inert gases is 1. This example: helium, neon, argon, krypton, xenon, radon. These are inert gases and can exist in monoatomic form. So we can say that the atomicity of these gases are 1. It means these are monoatomic gases. Now we will discuss about the ions. An ion is a positively or negatively charged atom or group of atoms. Ion is a negatively or positively charged atoms or group of atoms. This example: H plus, it is a ion of hydrogen. H represent symbol of hydrogen and plus represent the nature of charge. So this is a single atom with charge, so we can say that this is a ion of hydrogen. Cl minus, this is ion of chlorine, and we say chloride. Now SO4 2 minus, this is sulfate ion, and NH4 plus, this is ammonium ion, etc. If we write H, it is an atom, not an ion, because it has no charge, but H plus has 1 unit of positive charge, so we can say that this is ion of hydrogen and this is atom of hydrogen. In the same way, Cl represent 1 atom of chlorine, but Cl minus represent ion of chlorine because it has 1 unit of negative charge, and it is known as chloride ion, but it is atom of chlorine. So it is chlorine atom and it is chloride ion. In the same way, this is sulfate ion because it has 2 unit of negative charge, and this is ammonium ion, it has 1 unit of positive charge, and these species are positive and these species are negative. So we can say that negatively or positively charged atom or group of atoms are known as ions. This is an atom, charge atom, and this is a group of atoms with charge. Now we can classify ions in 2 manner. First one is on the basis of nature of charge, and second one is on the basis of number of atoms present in ion. Now you can say that on the basis of nature of charge, ions are of 2 types. First one is cation and second one is anion. Cation is positively charged ion and anion is negatively charged ion. Now we can take example. H plus, it has one unit of positive charge, so it is a cation. NH4 plus, it is also 1 unit of positive charge, so we can say that it is cation. Mg2 plus also has 2 unit of positive charge. Now we can add Zn2 plus, it is also has 2 unit of positive charge, and we can write arsenic 3 plus, and it is also positive charge species, so we can say that all of these are cation. And now we can take the example of anion. Cl minus, it is a chloride ion and it has 1 unit of negative charge. SO4 2 minus, it is sulfide ion, it has 2 unit of negative charge. And OH minus is hydroxide ion and it has 1 unit of negative charge. And CO3 2 minus is carbonate ion and it has 2 unit of negative charge. So all of these are anions because they have negative charge. Now we can classify ions on the basis of number of atoms present in ion in two categories. The first one is monoatomic ions and second one is polyatomic ions. Just an example. Now we can say that if ions has only one atom, then it is a polyatomic ion. Then it is a monoatomic ion. And if ion has more than one atom, then we can say that they will be a polyatomic ions. Now we can take an example. Cl minus, it has only one atom of chlorine, so it is a monoatomic ion. H plus, it has only one atom of hydrogen, so we can say that this is a monoatomic ion. Na plus, it is also has only one atom of sodium, so we can say that it is a monoatomic ion. But when we take example of NH4 plus ammonium ion, it has 5 atoms, 1 atom of nitrogen and 4 atom of hydrogen, so we can say that it has more than 1 atoms, that is 5 atom, so we can say that it is a polyatomic ion. Now we can take another example of SO4 2 minus, it has 1 atom of sulfur and 4 atom of oxygen, so overall it has 5 atoms, so we can say that it is also a polyatomic ion.